In this video, we are looking at how to find the median and interquartile range for grouped data. We use what is called a cumulative frequency graph. Firstly, we need to define some keywords. The median splits the data into two equal halves. The quartiles, as the name suggests, split the data into quarters. There are three quartiles, and the median is the one in the middle. The other quartiles are called the lower quartile and the upper quartile. Sometimes the quartiles are written as Q1, Q2 and Q3 as shown. The interquartile range is the difference between the lower quartile and the upper quartile. Before plotting the graph, we usually need to complete a cumulative frequency table. The table in our example shows the masses of 80 insects. We start by filling in the third column, which, like the first column, is called mass. In this column, however, we write the upper bound of each class from the first column. The first class goes from 0 to 10, so the upper bound is 10, and we write less than 10. The second class goes from 0 to 20, so the upper bound is 20, and we write less than 20. Why we write this will become apparent when we complete the cumulative frequency column. The third class goes from 0 to 30, so we write less than 30. The remaining rows are completed in the same way. Now we complete the cumulative frequency column. The values that we're going to fill in are the numbers of insects that have masses as indicated in the mass column that we just completed, in orange. 2 insects weigh less than 10 grams, so we write 2. 12 insects weigh less than 20 grams, so we write 12. These insects are the 2 that weigh between 0 and 10, as well as the 10 that weigh between 10 and 20. 30 insects weigh less than 30 grams, which is 2 plus 10 plus 18. The insects in the first three classes. Or we can just add the 18 onto our current subtotal of 12. The table continues in the same way. 30 plus 34 is 64, 64 plus 11 is 75, and 75 plus 5 is 80. Since we were told that there are 80 insects, we should expect the final value in this column to agree with that. This data has now been plotted onto a graph as shown, with the upper bound masses on the x-axis and the cumulative frequencies on the y-axis. This graph can be drawn with straight lines between the points. Now we are going to find the median. The median lies halfway up the graph, so out of 80 insects it is the 40th. We draw a line along from 40 to the graph and then drop it down to the x-axis. We shall read the value off at the end. The lower quartile lies a quarter of the way up the graph, so out of 80 insects it's the 20th. We repeat what we did for the median. The upper quartile lies 3/4 of the way up the graph, so it is the 60th. Reading the values off the graph, the median is 33, the lower quartile is 25, and the upper quartile is 39. Note that these are all estimates, and a little bit of leeway will be given. Recall that the interquartile range is the difference between the lower and upper quartiles, so in this example it is 39 minus 25, which is 14. Finally, we can use the graph to answer other questions too. Suppose that a competition for rearing oversized insects deems the heaviest 10% of the insects to be defined as large insects. What is the minimum mass an insect would need to be to qualify for the description of large? Since there are 80 insects, only 8 will be deemed to be large. As these are the heaviest 8, we read off the mass, which corresponds to a cumulative frequency of 72. The minimum mass an insect could be to be deemed large is 47 grams.